Imagine a vast ocean, its surface shimmering under the tropical sun. The light dances on the waves, creating a mesmerizing spectacle that stretches as far as the eye can see. This is the Pacific, the largest of Earth's oceans, a colossal body of water that covers more than 63 million square miles. It is a world unto itself, teeming with life and mystery. Within its depths, a fascinating dance of nature unfolds, the Niño Southern Oscillation, or ENSO. This phenomenon is a complex interplay of oceanic and atmospheric conditions that has far-reaching effects. This rhythmic cycle, characterized by fluctuating ocean temperatures in the central and eastern equatorial Pacific, governs not just the fate of marine life but also influences weather patterns across the globe. The changes in temperature can seem subtle, but their impact is profound. ENSO has two distinct phases, El Niño and La Niña. These phases are like two sides of a coin, each bringing its own unique set of conditions and consequences. El Niño, Spanish for the little boy, is marked by warmer than average sea surface temperatures in the central and eastern Pacific. This warming can disrupt normal weather patterns, leading to unusual and often extreme weather events. La Niña, the little girl, brings cooler than average temperatures to the same region. This cooling phase can also cause significant changes in weather, often opposite to those seen during El Niño. These seemingly small temperature shifts, often just a few degrees Celsius, set off a chain reaction that reverberates through the atmosphere, altering wind patterns, rainfall, and temperatures far beyond the Pacific Basin. The effects can be felt thousands of miles away, influencing weather systems on a global scale. Picture a seesaw, tilting gently up and down. This simple motion is a perfect metaphor for the ENSO cycle. That's the ENSO cycle, with El Niño and La Niña at opposite ends. When one phase is active, the other is dormant, and the cycle continues in a delicate balance. This natural climate pattern typically oscillates every 2 to 7 years, with each phase lasting for several months to a year or more. The duration and intensity of each phase can vary, making it a challenge to predict. Understanding this intricate dance of El Niño and La Niña is crucial to comprehending the complex tapestry of Earth's climate system. For regions like India, whose very lifeblood, the monsoon, is intricately linked to these Pacific oscillations, this knowledge is vital. The impacts of El Niño and La Niña are far-reaching, impacting agriculture, water resources, and ecosystems across the globe. In India, the monsoon season can be significantly affected, leading to either droughts or floods, which in turn affect crop yields and water availability. In the following sections, we will delve deeper into the mechanics of these phenomena, their global and regional impacts, and the implications for India, a nation intricately connected to the rhythm of the Pacific. We will explore how scientists study these patterns, the tools they use, and the ongoing research aimed at improving our understanding and prediction of ENSO events. To truly grasp the significance of El Niño and La Niña, we must journey beneath the surface, into the heart of the Pacific Ocean. This vast body of water holds the key to understanding these complex climatic phenomena. The Pacific Ocean, the largest and deepest of Earth's oceanic divisions, plays a pivotal role in global climate systems. Its vast expanse and dynamic nature make it a critical player in the Earth's weather patterns. Here, the interplay of wind, ocean currents, and temperature creates the captivating dance of ENSO, or the El Niño Southern Oscillation. This phenomenon is a natural part of the Earth's climate system, characterized by periodic fluctuations in sea surface temperatures and atmospheric conditions over the tropical Pacific. Under normal conditions, the Pacific Ocean exhibits a distinct temperature gradient, with warmer waters in the western Pacific and cooler waters in the east. This temperature difference is crucial in driving the atmospheric circulation patterns that influence weather across the globe. This difference in temperature drives a circulation pattern known as the Walker circulation. Named after Sir Gilbert Walker, this circulation involves the movement of air and water across the equatorial Pacific, creating a complex and dynamic system. Trade winds blowing from east to west push warm surface water toward the western Pacific, piling it up like a giant hill. This accumulation of warm water in the west is a critical component of the Walker circulation. This in turn draws cold, nutrient-rich water from the depths to the surface in the east, a process called upwelling. Upwelling is essential for marine life as it brings nutrients from the deep ocean to the surface, supporting a rich and diverse ecosystem. This cycle creates a stable atmospheric and oceanic system, maintaining a balance that supports predictable weather patterns and a thriving marine environment. El Niño disrupts this delicate balance. During an El Niño event, the trade winds weaken, sometimes even reversing direction. This disruption can have far-reaching effects on global weather patterns. When the trade winds weaken, the warm water that had accumulated in the west begins to move eastward. This shift in water movement suppresses the upwelling of cold water in the eastern Pacific, leading to significant changes in sea surface temperatures. This allows the warm water that had accumulated in the west to slosh back towards the east, suppressing the upwelling of cold water. The result is a warming of the central and eastern Pacific, which can have dramatic impacts on weather patterns. As a result, the central and eastern Pacific become unusually warm, while the west experiences cooler conditions. This shift in ocean temperatures can lead to changes in atmospheric pressure and wind patterns, affecting weather systems around the world. This shift in ocean temperatures alters the Walker circulation, impacting atmospheric pressure and wind patterns across the tropics. The changes in the Walker circulation can influence weather patterns far beyond the Pacific region. La Niña, on the other hand, intensifies the normal conditions. During a La Niña event, the trade winds strengthen, pushing warm water even further west and enhancing the upwelling of cold water in the east. The trade winds strengthen, pushing warm water even further west and enhancing the upwelling of cold water in the east. This creates an exaggerated temperature gradient across the Pacific, with cooler than average conditions in the central and eastern Pacific and warmer than average conditions in the west. This creates an exaggerated temperature gradient across the Pacific, with cooler than average conditions in the central and eastern Pacific and warmer than average conditions in the west. The enhanced temperature gradient can lead to significant changes in weather patterns and oceanic conditions. These changes in ocean temperatures also influence the Walker circulation, but in the opposite direction to El Niño. The strengthened trade winds and enhanced upwelling during La Niña can lead to cooler and drier conditions in some regions, while others may experience increased rainfall and storm activity. These seemingly subtle shifts in ocean temperatures and wind patterns have profound consequences. The changes in sea surface temperatures and atmospheric circulation can influence weather patterns across the globe, affecting everything from rainfall and storm tracks to temperatures and ocean currents. The altered atmospheric circulation affects the formation and movement of weather systems worldwide, leading to changes in rainfall patterns, storm tracks, and temperatures far beyond the tropical Pacific. These changes can have significant impacts on agriculture, water resources, and ecosystems. In the next section, we will explore how El Niño and La Niña influence weather patterns on a global scale. We will examine the far-reaching impacts of these phenomena, from droughts and floods to changes in marine ecosystems and global climate patterns. Pause 3S, Chapter 3. Impact of El Niño and La Niña on global weather patterns. Pause 2S. The influence of El Niño and La Niña extends far beyond the Pacific Ocean. These climatic phenomena can dramatically alter weather patterns across the globe, affecting millions of lives in diverse ecosystems. Let's explore some of the most significant impacts. Pause 2S. During an El Niño event, the warming of the central and eastern Pacific Ocean disrupts normal atmospheric circulation. This can lead to a variety of extreme weather conditions. For instance, regions like the western coast of South America may experience heavy rainfall and flooding, while Southeastern Asia and Australia often face severe droughts and increased wildfire risk. Pause 2S. Take the El Niño event of 1997 to 1998, one of the strongest on record. It caused widespread flooding in Peru and Ecuador, devastating communities and infrastructure. Meanwhile, Indonesia and parts of Australia suffered from intense droughts, leading to water shortages and crop failures. Pause 2S. Conversely, La Niña typically brings about cooler and wetter conditions in some regions while others face drier and warmer weather. For example, the enhanced upwelling of cold water in the eastern Pacific can lead to increased rainfall in places like Southeast Asia and northern Australia, often resulting in flooding. At the same time, the southwestern United States may experience drier than normal conditions, exacerbating drought situations. Pause 2S. The La Niña event of 2010 to 2011 serves as a poignant example. Australia saw record-breaking rainfall and flooding, particularly in Queensland, causing significant damage and economic loss. On the other hand, the southern United States experienced severe drought conditions impacting agriculture and water resources. Pause 2S. These case studies highlight the far-reaching consequences of El Niño and La Niña. The changes in sea surface temperatures and atmospheric circulation do not just alter weather patterns temporarily, they can have lasting effects on agriculture, water resources, and entire ecosystems. Pause 2S. Understanding these impacts is crucial for preparing and adapting to future events. As our climate continues to change, the frequency and intensity of El Niño and La Niña events may also shift, presenting new challenges and uncertainties. Pause 2S. In the next chapter, we will delve deeper into the science of climate prediction and how researchers are working to forecast these phenomena. We will explore the tools and techniques used to predict El Niño and La Niña events, and how this knowledge can help mitigate their impacts. Pause 2S. Stay tuned as we continue our journey into the fascinating world of climate science. Chapter 4. El Niño and La Niña, Economic and Social Impacts. Pause 3S. While the physical impacts of El Niño and La Niña on global weather patterns are profound, their economic and social consequences are equally significant. Let's delve into how these climate phenomena affect key sectors such as agriculture, fisheries, and disaster management. Pause 2S. Agriculture is often the first sector to feel the brunt of these climatic events. Pause 1S. During an El Niño event, regions that experience drought, like Australia and Southeast Asia, see substantial declines in crop yields. This not only leads to food shortages but also drives up prices, affecting food security and livelihoods. Pause 2S. Conversely, areas that receive excessive rainfall, such as parts of South America, may suffer from soil erosion and crop damage, further straining agricultural productivity. Pause 2S. La Niña events, with their contrasting weather patterns, bring their own set of challenges. Pause 2S. For instance, the increased rainfall in Southeast Asia and Northern Australia can lead to bumper crops in some cases, but also raises the risk of flooding, which can destroy harvests and infrastructure. Pause 2S. In the southwestern United States, drier than normal conditions can exacerbate droughts, stressing water resources and reducing agricultural output. Pause 2S. The fisheries sector is also heavily impacted by these climatic shifts. Pause 2S. El Niño events can lead to warmer ocean temperatures, which disrupt marine ecosystems and reduce fish populations. This can severely impact coastal communities that rely on fishing for their livelihoods. Pause 2S. For example, the Peruvian anchovy fishery, one of the world's largest, often sees significant declines during strong El Niño events, affecting both local economies and global fish markets. Pause 2S. In contrast, La Niña can enhance marine productivity in certain regions due to the upwelling of nutrient-rich cold water. Pause 2S. However, the benefits are not uniformly distributed, and some areas may still suffer from the adverse effects of altered ocean conditions. Pause 2S. Disaster management is another critical area where the impacts of El Niño and La Niña are felt. Pause 2S. The extreme weather conditions associated with these events, such as floods, droughts, and storms, necessitate robust disaster preparedness and response strategies. Pause 2S. Governments and organizations must invest in early warning systems, infrastructure resilience, and community education to mitigate the risks and protect vulnerable populations. Pause 2S. For instance, the El Niño of 1997 to 1998 prompted significant advancements in disaster management practices globally. Pause 2S. Countries that were better prepared with early warning systems and response plans fared much better in minimizing the loss of life and property. Pause 2S. Understanding the economic and social impacts of El Niño and La Niña is crucial for creating resilient communities and economies. Pause 2S. As we continue to face the challenges posed by climate change, investing in research, adaptation strategies, and international cooperation becomes increasingly vital. Pause 2S. In the next chapter, we will explore the science of climate prediction and how researchers are working to forecast these phenomena. Pause 2S. We will delve into the tools and techniques used to predict El Niño and La Niña events and how this knowledge can help mitigate their impacts. Stay tuned as we continue our journey into the fascinating world of climate science. Pause 2S.